So now we are in the Python environment, and so we are basically going to write up a very simple, basic calculator that calculates the Ficks first law. The formula for the Ficks law, and I'm going to write that right here. Ficks law calculation, that is dj is equal to minus d multiplied by c2 minus c1 divided by L. So we basically have our diffusivity, which is d, multiplied by the change in concentration divided by the thickness of the slab. Now the thing about Python is that all the variables that you are applying within the formula, because Python code runs from top to bottom, that means that your line 3 runs before your line 4. That means that whenever you are running a formula, all of the variables, they have to be defined in the lines before you write up the formula. So what we're going to do now is then we're going to go up and then we're going to ask the user the inputs for each of the variables. So you have your D, which is our diffusivity. Then we have our concentration, the second concentration, and the length of the slab. Then I'm going to write float because we want the input to be stored as a number. Actually, you know what? I'm going to write the input first, and then I'll show you diffusivity. If I can spell it right, there we go. That is D, and that is in meters squared per second, and that would be the very first value. Now, the reason I wrote it, and I'm going to write the comments there just to hide it for now. If I run this function and I store a value, let's say 25, then you can see in the variable explorer that that value is stored as a string. The problem is that strings cannot be used to perform numerical operations in Python. Therefore, we would have to convert that into either an integer or a float value. So we are going to go and convert that into a float function, a float data type. A float is something that is kind of the data type that uses the decimal numbers basically in Python. And then I'm just going to copy paste all of these right there and there. And then we'll get rid of the comment there. Then I'm going to write my concentration on side 1, that is C1, and that is in moles per cubic meters. And I think I can actually, if I can, there, yes, I can copy paste this line right there. And that is C2, and that is site 2. And that would be the length of the slab, and that is L in meters. There we go. So now once we have all of our variables, then we can now successfully run our formula. Because when you look at J, if you have D, yes, we have D, C2, yes, C1, yes, and L, yes. So if I was to run the function now, then if I was to run the formula now, then we would be able to calculate the output value J. But the user itself will not be able to see the output unless we actually print the result for them. So we're going to write in, and then we're going to write diffusion flux J, and that would be there in a curly bracket. And then since the variable that we have is J, then we're going to write -4E, and that would be moles per meter squared times S. And I hope I can write that up. There we go. There we go. Now, what this E means that we want the result to be in scientific notation for the 4 decimal places. The N that I wrote right here, that is basically just a line break in Python. And this should actually be a semicolon and not the other one. So if I was to run the function now, if our diffusivity is, let's say, 1E minus 9, and the concentration is 25, on the other hand it's 10, and the length is, let's say, 2 meters, then we'll see that the diffusion flux is calculated to be 7.5000 to the power of -9, and that is what this -.4e means. If I had written an F instead of an E, then we would have actually received an actual decimal places. So let's say I write 25, 10, 2, then you'll see that you get the answer in 4 decimal places. But that answer is more or less useless, because what if our answer is much, much, much smaller, and therefore we need to use scientific notation. And therefore in Python, then you have to tell Python that the result that we want to receive for the user should be in scientific notation, and that is done so by using E. And this .4 that I wrote before, that basically tells Python that you need to write the answer in 4 decimal places. We could have changed that to 2. So if I run it again, then I will once again write 1e minus 9, 25, 10, and 2. Then you'll see that you only get 2 decimal places. So it really comes down to, how much accuracy you're looking for in your code. If you are merely looking for 2 decimal places, 4, whatever, and you can choose as many as you like. So obviously, depending on the type of problem that you're working with or the situation you have, you can change this decimal places as you go. So that's essentially how you would set up a calculation for your Ficks law in Python. So we really hope that was helpful, and stay tuned for more videos on how Python can be used in chemical engineering. And do not forget to like, share, and subscribe to Chemical Engineering Life for more videos.